Hey guys, sorry about my voice. I have a little bit of a sore throat. Today is the last installment of Matter and Change. By the end of this video, you should have a firm understanding of the different phases of matter, the energy change accompanied with a phase change, and how mixtures can be separated. A state of matter or a phase of matter can be defined as a solid, liquid, gas, or even plasma. Plasma is the fourth phase, but we will not be focusing on it very much this year. Any of the phases mentioned can be determined by the arrangement of particles. Temperature and pressure do affect the state of matter because the phases of a substance depend on it. For example, gold is usually seen as a solid. If you alter the temperature and the pressure, you can create a gaseous version of gold. Every substance can change its phase. So whether you think it's currently a solid, a liquid, or a gas, by changing the conditions of temperature and pressure, we will be able to change their phase. As mentioned, to identify the phase of matter, it is important to understand its particle arrangement. Solids have a definite volume and definite shape. This is due to the fact that solid particles are very tightly packed together. I'd like you to look at the picture to the right. You'll also notice that solid particles have a very organized pattern to them. Because of the arrangement, solids cannot be compressed or squeezed to eliminate the empty spaces and cannot take the shape of their containers. Liquids have indefinite shape, flow, and have a fixed volume. Their particles have some space between them, which allows the particles to move more freely. This is what we refer to as flow. Because of this, particles of a liquid are not in a fixed pattern. Due to their particle arrangement, liquids will take the shape of their containers. Gases have indefinite shape and volume. Particles of a gas are very spread apart, leaving lots of space between them. This is why we can compress gases, because as we mentioned, compression means that we're going to eliminate the space between those particles. Finally, due to their particle arrangement, gases will take the shape and volume of the container they occupy. Here are what the particle diagrams would look like. Again, solids have an orderly pattern and do not take the shape or volume of the container. Liquids have a little bit more movement and take the shape of their container, but notice they do not take up the volume or the entire space of the container. Gases, however, take the full volume and exact shape of its container. This is because particles have a lot more movement. I will briefly describe plasma, as we will not really be using it in class this year. Plasma is charged or ionized gas particles. When this occurs, the gas becomes conductive like a metal. Plasma is actually the most abundant phase in our universe, though, because stars are in plasma states. Like gases, plasma has indefinite shape and indefinite volume. In order to change from one of these phases to another, energy in the system must be altered. There are many different types of energy. On the slide, I have listed a few examples of the types of energy we will be discussing this year. Now, in order to change a phase, heat energy must either be gained or lost. When the energy is lost, we say the system is exothermic. This means the system will cool down. When energy is gained, we say the system is endothermic. This means the system is heating up. Let's take a look at the different phase changes and determine if they are endo or exothermic. Solid to liquid refers to melting, and that is endothermic. Liquid to gas, which is called boiling or evaporation, is also endothermic. Solid to gas is sublimation, and again, endothermic. The reason why these three examples are endothermic is because they are all heating up. In order for a solid to become a liquid, heat needs to be gained. Next, we have gas turning into liquid, which is condensation. This is exothermic. Liquid turning into a solid is known as freezing or solidification, and again, exothermic. Finally, a gas turning into a solid is called deposition, and this is also exothermic. The last three examples are exothermic. In order for gas to turn into a liquid, heat must be lost so that it may cool down. The same thing goes for liquid to solid and gas to solid. Now we are in the last part of the unit. Here we will describe the different separation methods of matter. As we have discussed, compounds can only be separated by chemical changes since they were originally created chemically. And elements are the only type of matter that cannot be broken down by physical or chemical means. As for mixtures, they can only be separated by physical means, since they were created physically. There are many different methods of physical separation. Filtration is a separation method only used for heterogeneous mixtures like sand and water. The way it works is that the filtrate, or the liquid in the heterogeneous mixture, flows through the filter paper, leaving the undissolved particles behind, or the solid particles behind. Think of coffee being brewed. The liquid solution goes through the filter, but the coffee grinds get left behind. Watch glass evaporation is a method of separation for homogeneous mixtures like salt and water. The mixture is placed in the watch glass, which is slowly heated by boiling water. As the mixture heats, the solvent, or the liquid, evaporates, leaving the solute, or the solid, behind. Crucible evaporation is similar to the watch glass evaporation, but the homogeneous mixture appears to be solid. We use this method to remove any liquid trapped between the solid particles. Distillation is one of the more important types of separation methods on the Regents exam. Distillation is used to also separate homogeneous mixtures, but in this case, it's going to be a homogeneous mixture made up of liquids. This method only will work if the substances have different boiling points from each other. As the mixtures are heated, the liquid with the lower boiling point will evaporate and will then be condensed and cooled down into a liquid again. Finally, we have chromatography, another method for separating homogeneous mixtures. Chroma comes from the Greek word color, and graphy comes from the Greek word to write. As you can probably put it together, chromatography separates substances by different colors or pigments, and they are written on the paper used for separation. As the colors separate, they will end up on a different area from each other because of the differences in their sizes. This ends our unit. Review any previous notes and videos so that you are prepared for the upcoming test. See you guys in class.